Hello and welcome to the Star Bethlehem second version or second video. Today what we're going to do is we're going to look at a computer program called Starry Night. It's digital planetarium software that we can use to see if some of the things that we talked about in the Star Bethlehem video are true or not. And basically what we're looking at now is the view from Jerusalem. You can set your location, which I'll show you how to do later in the video. You can set your location to Jerusalem. It tells you the current time, and you can change the way time moves. So right now you're seeing time move really fast, so that we could get to the nighttime and we can see, so we're a little advanced in time versus, currently when I made the video, and probably currently when you're watching it, it's during the daytime, although you might be watching at night. And so with Starry Night, you can pan around using the hand tool and look at different places in the sky. Like I said, that is from Jerusalem, from the perspective of being at Jerusalem. You can advance time, as I said before. Now we're going to, and you're seeing little things moving around. Time is advancing right now, and if you pay close attention, you can see that the stars were moving. So basically, that's one of the things that came up in the Starry Night video. The other thing we're going to do is right now I'm not moving in time, but we're looking straight up now. If you look at the elevation angle, we're looking up at 90 degrees, and I'm zooming in to show the skies over Israel don't have a lot of stars in them directly overhead. The stars that you see here are very low in magnitude, and so and I'm going to put the hand tool over some of the stars. You can see the magnitudes are down near 5.7. That's a very dim star. It'd be very difficult to see with your eyes, and so most of the stars in the sky at this point, remember this is around midnight. If you look straight up from Jerusalem, you don't see a lot of bright stars. And then what we're going to do next is zoom out a little bit to be more consistent with the view you would have from without a telescope. And we're going to advance time. Now this time is advancing 30 times faster than normal, but what you're seeing is in a very short period of time, any stars that were directly overhead, a few minutes later even, really won't be anymore, and new stars will appear overhead that are coming into the field of view. And so basically, according to the story of the wise men, they got to where Jesus was born, and they perceived that the star rested over their location, meaning straight up ahead. Well, none of these stars that we normally see in the sky over Israel are resting overhead. And so it's pretty obvious to see that no normal star is going to be the Star of Bethlehem. And actually, if any of these stars were supernova, like if they were going very bright temporarily, they would still move across the sky the same way. They would just be brighter. So it is possible there was a bright star in the sky around that time, but that if it was a star, an actual star, it would be moving across the field just like you saw the stars moving a moment ago. So that's kind of where we are with with how stars work, and so now what we're going to do next is we're going to learn how to find things with Starry Night. So I'm pausing the video and then I'm restarting again. And so what we're going to use is the find bar. So there's this toolbar on the side here. If you click the find button, a menu comes up and you can type in objects in the sky that you would like to find. Now we've already looked at stars. We're going to look at see, I think the first thing we're going to look for is Jupiter. It's a planet. So some people have theorized that that the star of Bethlehem was a planet. And what you see here is this is Jupiter. So as seen from Israel this time of year. And what you see is, what you're seeing now is Jupiter as it would be viewed through a small telescope. You can actually see some of the moons of Jupiter. But the wise men wouldn't have had a small telescope, probably. So I'm going to zoom back out so you can see Jupiter, a very bright planet, as if it would be seen by them. You think, well, that could be the Star of Bethlehem, maybe. But if you actually notice, we're looking directly at Jupiter, and it's only, we're not looking 90 degrees straight up. For the most part, unless you're at the equator, or you're at a time of year when the Earth's tilted towards the sun, the planets don't appear to be directly overhead. They appear low in the sky. In fact, if it were Israel's in the northern hemisphere, so Jupiter would have been the Earth would have been tilting away in the winter time from the Earth in the northern hemisphere. It would not be high in the sky at all, as I'm showing here. Now I'm looking higher up. I'm looking at like at 45 degrees or 50 degrees up. Jupiter is not high, it's low. It would not appear, and as the stars move, Jupiter moves with them. So you can see now I'm advancing time, and you can see the stars moving. Jupiter is still very low in the sky, and it actually is following the path that the sun takes across the sky. So it will never appear overhead, and it will never come to rest. So the chances that a planet or a planetary conjunction would be mistaken for as something directly overhead of the place where Jesus was born. Now I'm looking almost straight up. You can see the planets just don't get straight up. You'll see Jupiter will come into view in the bottom corner, but it's on a trajectory to not reach the center there. So this is not a viable theory, at least that is consistent with the story told in the book of Matthew. Which, if you believe the Bible is true, then this account, there's no reason to discount the testimony given there. However, if you don't believe the Bible is true, then you might very well say, well, it's just a story, and then that's where you get on the path of thinking all these other objects might be the Star of Bethlehem. Now, another object we're going to look at is, in the video we talked about comets. So let's see if we can find a comet. We're going to look for Halley's Comet. As it turns out, this time of year, Halley's Comet does appear in the sky as seen from Israel, but it's a kind of a morning. It's early in the morning it will appear. So we're going to advance in time, which is going to take us into the day, where you'll see the sun up there, and there's Halley's Comet in the sky. And what we're going to do is go backwards in time to have the sun go back to sunrise, so we can see Halley's Comet in the sky at a time where it's dark outside. So you can see that's how the sun, now it turns out all the planets and most comets move along the path through the sky. It's called the ecliptic plane. And most of these objects are in the ecliptic plane. It's where all the planets and most of the comets orbit the sun. And so from the Earth's perspective, with our rotation, it appears as if the sun and all the planets move along this path across the sky, which doesn't, unless it's the summer, the sun won't appear overhead in the northern hemisphere, like up near 90 degrees. In the winter, the sun will always be very low. So now we're seeing the Halley's Comet at night. You see it's moving along with the rest of the stars, and so it's basically even a bright comet really wouldn't be mistaken for the Star of Bethlehem based on the way it moves through the sky, so it doesn't come to rest. And on top of that, it wouldn't be overhead. So now I'm going to show you if there, what a satellite would look like. And this is going to take me a little bit of time because there's only one satellite in the database of Starry Night. It's the GOES-N satellite, and so I'm trying to see if there's any other GOES satellites. And now I realize that GOES-N hangs over the world way in the east, much farther east than Jerusalem. Probably where, who knows, maybe where the wise men came from originally. So what we're going to do is, GOES is a geo-orbiting satellite. And so we're going to see how these kind of satellites move to the sky at night. And so this is how you choose your home location. You go to the file menu, and there's select home location button. And you can choose different places on the Earth. Right now I'm looking for Rio de Janeiro. I was going to try a place in the southern hemisphere to see if that made the, I was trying to figure out, because right now GOES is not visible from Jerusalem. So we're going to pick another place on the Earth. And I'm just switching from the north to the south latitude first. And I'm going to try to find GOES again. So now we're in the southern hemisphere. I just changed north to south on our longitude and latitude, and GOES-N is still not visible. So it turns out it's not a north-south problem. It's a problem with that this particular satellite is in geosynchronous orbit on the other side of the world, so it's not visible from this side of the world. So now this is the map tool for choosing a home location. I still was not sure at this point when I was making the video whether it was a north-south or east-west problem. So I switched to a place in Brazil, and I still can't see the satellite. So I'm going to choose a new home location. Again, I go to File and Set Home Location, and you can do it from a list of cities there, or you can use the map. Now I'm going to choose a place. I'm going to choose Ohio. So I've chosen Ohio, and now I can see the GOES satellite, you'll see. And I'm going to, Starry Night is taking me to where it would be viewed, but it's down right on the horizon. So from Ohio, this satellite appears to be just on the horizon. It's very far west of us. So it's in the far east, which is also west of the United States. So again, I'm going to move up into Canada, not being sure at this point whether it was a north-south or east-west problem, still thinking it was a north-south problem. And I moved directly north and found the satellites in the exact same place, due west of my location. So it finally dawned on me, and I can advance time and see that the stars are moving, but the geo-orbiting satellite isn't moving because it's going around the Earth at the same rate the Earth rotates. So it won't appear to move when the stars move. And that would be much more like the Star of Bethlehem. And it could be hovering directly over a spot on the Earth. Now, of course, back, when Jesus was born, we don't believe that we had any geo-orbiting satellites. So now I'm moving to a new location, and I'm going to set the location, go to the map, and then this time I'm going to go to the West Coast. So it started to dawn on me that this is an east-west problem. That's why I can't get GOES to be where I need it to be. And from the West Coast of the United States, if I click on GOES-N, now it appears above the horizon, so it would be visible. In fact, the further west I go, the higher in the sky it will be. So now I'm going to let time pass more quickly, and you can see that this object would appear, if you were directly underneath it on the surface of the Earth, which would be over in the far east somewhere, this object would appear to be at rest over your location. Now, the reality is our geo-orbiting satellites are not visible to the human eye. So you wouldn't see, there's no way a satellite, geo-orbit is 36,000 kilometers above the surface of the Earth. So there's absolutely no way that could be, still be a star of Bethlehem. It would have to be a very bright object that humans could see with their own eyes that is over that location. Now, the final thing we're going to do is look at a bright star like Polaris. Now, Polaris is the one star that we're going to advance time here. And as you see, as time advances, the stars all move around Polaris. So Polaris is the one star that does appear to be at rest in the sky. And there is a place on the Earth where Polaris would appear to be overhead. So what we're going to do is we're in California, we're going to move farther north into Oregon or Washington. And if you note how high Polaris is in the sky now, we're going to move to this new location and move to where Polaris is. So when you move to a new location, Starry Night always has you facing south. I'm not sure why. So I have to, but you see, before we could see, when we were in California, we could see the Polaris was a little lower. Now we moved into the northern part of the West Coast. Polaris is a little higher in the sky, and we're going to go into Canada and move there, and then find Polaris again, and you'll be able to see that we have to look higher in the sky to see Polaris. Now you can't even see the ground, see the horizon. Polaris is much higher in the sky. In fact, if you go down to the ground, Polaris almost moves off the top of the screen. And then finally, what we'll do is we'll move all the way to the North Pole, where Polaris would be over the North Pole. And then you get a little sense, in fact, the Star of Bethlehem would behave a lot like Polaris, in that if you walked from California up to the North Pole, the Polaris would proceed ahead of you and then move slowly above you to where, if you move all the way to the North Pole, Polaris would appear to be directly overhead. So we go there and we click on Find Polaris. Starry Night takes us to Polaris, and now you can see the elevation. We're looking straight up now, at 90 degrees. And I'll hit the Z button to finish our trip to look completely up at 90 degrees, and there's Polaris. We can zoom in. See that brighter star there, that's Polaris, and it's bright. It's got a magnitude of close to 2, much brighter than a magnitude 5 or 6 star. It's 100 times brighter, actually. So for every 3 orders of astronomical magnitude, you get a factor of 100 in brightness. So this pretty much concludes our discussion of the Star of Bethlehem, as you've seen from a digital planetarium. And if you have, we're going to continue this discussion now by going outside and looking at the through a telescope.